I had this sent in to the channel by Kaiweets. This is a multimeter, and it was donated for a review. We'll take a look at it. The Kaiweets brand you will see on Amazon. There's another brand name in the same company called Habotest, H-A-B-O test, Habotest, and you will see those elsewhere, but they're the same company and I believe the same meter. So this was sent in for review. This is a Kaiweets KM601, and I believe it's the same meter as the Habotest HT116. And we'll take a look at these. Both of those meters are 10,000 count or 999 count meters, more accurately. So what comes in the package? You get the meter a little bit on the big side. It's got some heft to it. Let's see. Let's compare it to something we know. Here's a Unity 61. So, you know, it's fairly heavy. It's going to be a lot thinner, but yeah, it's a little bit lighter than this, but it's not a small meter, right? So this is what's known as an auto meter or a smart meter, and we'll talk about what that means. But let's get back to what was in the case. I like the case. It's these little kind of these little hard little clamshell things, and it comes with the standard probes. These aren't great probes. They're not gold plated. Yeah, the wire's a little bit stiff. It also comes with a temperature sensor, a thermistor, so it can measure temperature, and it came with batteries. It uses AAA batteries, and it came with 2 sets of those, so I put one in, but it did come with two sets of those. That's not always a good sign in my mind. It says that maybe this thing draws too much current. Batteries should last a long time. I don't know what the battery life in this thing's going to be, but yeah, we'll take a look. So kind of feels like a laptop, I mean a tablet, you know, or one of those giant cell phones. It has a button on the top. We'll press that, and you get this cool display. So this is kind of like the cool thing, right? It's completely auto too. So it's supposed to be smart, and it's supposed to figure out what it is you're doing and do the right thing, whether it's volts or ohms or whatever. We'll see if that's going to be true or not. I'm not a big fan of auto meters, but nice big display. So I do like the readability of the display. Now, there's a good thing about the display and a bad thing about the display. The good thing about the display is it's very readable in this orientation. There is no bail on the back to set your meter up, but if you notice, there's no viewability if you set your meter up also. So the LCD is designed to be looked at from an angle in this direction only, not this direction, right? It goes black on you. So they know that it's got to go flat. And so you're going to be looking at it this way, and so that's the way it's just designed. All right, so one of the other things I don't like is it has these right angle banana jacks, and that means that you can't put them in straight, and if you put them in, they're going to be kind of up and in your way. Now, a lot of the photographs show them folded down flat, but that means you have one lead on one side, one lead on the other side. That doesn't make any sense, and you really can't bend it over. Anyway, so that's just kind of a minor gripe. You could swap them out for some leads that go straight in. That would be fine. And so, you know, if you touch the leads together, it says, "Oh, you must be doing continuity." So it automatically did that. So anyway. Yeah, we'll take a look at all of the functions a little bit later. I wanted to talk about the meter itself, though. It is a 999 count meter, and I've had questions from viewers before. What does that mean? People are very confused about what does it mean? It counts in a meter, and so let's talk about that a bit. A 9999 meter means that you have 4 digits, And each digit can go between 0 and 9, okay? And that's all it means. Now, if you have a 6,000 count meter, they can go from 0 to 6,000. Well, what does that mean? Well, you can't display 7000 because it only can go up to 6. So if you had to display 7, you could only display 700. It would have to shift down one, okay? And so it's almost like a counting system, right? You count up and then you have to shift down. But 999 can display 0 through 9 in all 4 places. 6000 can display 0 through 9 in these places, but only 0 through 6 in this place. And then there's some 4,000 count meters. And a 4,000 count meter can display 0 through 9 here, but only up to 4 here. And it's probably 3. Okay? They call it a 4,000 count meter, but it probably is 3999. And here it's probably 5999. And then it has to shift down, and then you lose resolution, right? You have maximum resolution when you have the biggest number. But with 9999, you always have good resolution. So that's the mark of a good meter. Some of the meters go even higher than that. You'll have a 20,000 count meter, a 50,000 count meter, and that they have to add another digit, right? So if you had a 20,000 count meter, you could display 1999. So it's like and other things people call them is like a 4.5 digit meter, 4 and a half, even though it's not quite a half. Anyway, there's a lot of confusion about how they describe meters, but that's for later. Okay, so we can automatically select the function by pushing this. So we're in volts, we're in ohms, we're in continuity, diode checker. It has capacitance, millivolts, no microvolts, but it has millivolts, hertz and percent duty cycle, temperature by thermocouple. It has a AC line detector, so it has a built-in sensor on the top. Or you can set it for live mode, which is that you can use one of the probes and you can stick it in an outlet and see if you're live or not. And then it has milliamps and it has amps. Now, one of the nice things about the meter, or whatever, is when you're doing volts, it says, hey, you should plug into these two things here, right? I'll go here to volts, and it says, yeah, these two banana jacks, it has multiple banana jacks on the bottom. It says, these are the ones you should be using. We go to ohms, it says, these are the ones you should be using, the LEDs flash. Continuity, these are the ones you should be using. Diode. So most of these, you're only going to be using COM and then this one. But now when we get to milliamps, it says, oh, no, you need to use these two. You need to have this. So if you've made the mistake of trying to measure current with these two, it doesn't work. And so it tells you these two. And then you go to 10 amps, it says, no, use this banana jack over here. So that's kind of neat. I kind of like that. All right, let's see. It has auto power off. 9999 counts. It has a flashlight built in, which is kind of gimmicky. I'm not sure about that one. And it's on the bottom, maybe on the, I don't know. Well, no. It has a flashlight. It has a power switch, and it has an APO, automatic power off. Oh, maybe that's so you can tell it. Yeah, tell it don't power off. In case you don't want it to turn off. Okay, what should we do? Let me talk a little bit about the meter itself, and then we'll make some measurements. If you go on YouTube, you can find some other people who have ripped these things apart. I'm not going to rip mine apart. I'm not a multimeter review guy. A lot of people know the insides, whether there's enough, leakage current between certain things and if it's made right and everything. I'm not one of those guys. I just use them. But I do know that it uses this chip inside. So there's a couple companies that you can get chips from. This is one, SDIC. I forget what it stands for, SDIC Microelectronics. There are a couple others. Let's see. Just for completeness, the other companies are Hycon, Hycon, and Fortune. So there's probably some other ones as well, but those are the three that I know about. And this chip here is for a 4,000 or 6,000 count meter. There's a 7502 that I could not find the data sheet for, but this meter uses the 7502, which is the 9999 count meter, okay? And but it should be very similar to this chip. If you've never seen these chips before, they're basically the whole multimeter all on a chip. So they have a multiplexer, so they can measure 8 different inputs. And they go into this A to D. This one has a 24-bit A to D, I believe, 23 or 24-bit A to D. And then it goes into a microprocessor that you can program. It has 16 kbytes, but they're one-time programmable. So once you burn it, it's dead, no more. So do it right. Some RAM. It has an LCD driver, so you can turn this thing into a multimeter just by doing this. So they have an example here. Here's the display, here's the chip, here's your buttons, here's all of your switching over here, here's your power supply, and yeah, so you build a DVM, you just get a chip and you're done. And then if you want to add stuff to it, then you can learn how to program it and put your own program in to customize it and stuff for you. Anyway, I wanted to show that, but let's go off and make some measurements and see how this thing does. All right, let's see if I can balance this thing here. Yeah, I think it'll balance there. All right, and I've got terrible glare. Of course. Of course. Okay, there we go. So we are measuring 1 volt, and we are going to trust this meter because it's very accurate. So 9997, and we're getting 999, so yeah, very nice. Let's try some other voltage ranges. Let's go to 10 volts. Looks great. 100 volts. A little low. Well, 999. Yeah, we'll call that weigh and spec. Very nice. Let's measure some smaller voltages. We'll go to the millivolts range here. And we are at 100 millivolts, and it thinks we want to do ohms measurements. So yeah, fail there. So let's go ahead and change it to millivolts up here. There we go. 100 millivolts, very nice. And let's do 10 millivolts. Wow, 10 millivolts. So I'd say, yeah, it's pretty spot on. And I'm just getting all of the glares, aren't I? There we go. Sorry about all that. There's the 10. There's the 100. And it's looking good. Let's see. Let's go. What else do we want to measure here? I don't think we need to measure anything else here. It seems to be pretty spot on for DC volts. Let's go ahead and measure some ohms. Ohms is next on the list. All right, so I made these clip leads here. They go in and they just go to banana jack, so that's what I'm that's what I'm doing to make these measurements easier. So let's go ahead and connect this up to the ohms range, and we will select ohms. There we go. And we are measuring 1 megohm. And that looks like it's true. Let's go to lower ohmage. So we're going to start at, let's see here. This is 100 ohms, okay. 101, 105, okay, good. Let's see if this thing zeros. Let's short these out and see if it goes to 0. Yeah, it says 0 ohms. Okay, so we're okay. So if there is any error here, it is the error. So we're at 100 ohms. Let's try low ohms. Oops. Let's go here to 10 ohms, measuring 10 ohms. And then let's dial in 1 ohm. And 0.8, okay. Let's go up. We'll go to 1 k ohm. 10 k ohm, wow. 100 k ohm, very nice. And 100 k ohm, and then we can go one more, we can go to 1 megohm, 0.999. So I'd say ohms are measuring quite well. So next on it is the continuity beeper. So let's try that out. Okay, so it is not fast. You have to hold it down quite a while. Yeah. So it is a latched beep, but it's a very slow to react latched beep. So you don't get any scratchy beeps, so that says it's latched, but you can see that I'm making contact intermittently, and it's just hard at catching them at all. So it's not the greatest continuity checker, but it does work. All right, and next thing on the list here is diode test. All right, so let me rearrange things a bit. So I have this little tester board that I put together. It has a germanium diode, a silicon diode, a red LED, and a blue LED, so we can measure the V off of those things. They're all different. And this says, I think I can get it all on the camera. Yeah, I get it all in the same shot here. This one says it's 0.3 ohms. That's the germanium. Here's the silicon, 0.6 volts. Here's the red LED, 1.86 volts. And here's the blue LED, 2.6 volts. So it does have the ability to go, I think, go up to about 3 volts. But most of these meters go up to about 3 volts. And then they stop working after that. But yeah, I'd say that works great. Let's see, capacitance. Okay, capacitance. Let's measure a few capacitors. Let me find my calibration standards. All right, let's see here. Let's connect up to a known capacitor. See what it says. So this one is 39.2 nanofarads, and this one is 38.47. So it is high. And what is the spec? What does the book say the spec is on capacitance measurements? Probably not very good. Capacitance, 4%. 4 to 5%, depending on the range. So we could do a calculation here. 30. Let's see, it's supposed to be 38.47. And we're getting 39.25. That is 2%. So certainly within spec. This capacitor is plus or minus 0.3% accurate. This one is 0.3% accurate as well, and it is a much larger value. Let's try it out. It is 100 nanofarads, and I'd say that's awful close. So that one is in spec, and I got a couple other ones, so why not just measure them all? This one is, yeah, these are all 0.3. Oops, oh man, dropped on the ground. Oh, now it's not 0.3 anymore. No, I'm sure it's fine. These are like mil spec things. 1608, and it's supposed to be 15.7. So let's see. Let's run the calculation on that one. Supposed to be 15.72, and it is 16.08. .2%, close enough. And I've got some other ones here that are accurate. Let's see what this one measures. This one's supposed to be, what's it measuring? 601, it's supposed to be 590. But this one's only plus or minus 1%, so not as accurate as the other ones. And what value were these? I forget what value these were. These are very accurate ones as well. These are all Soviet Union capacitors, I think. Let's measure this one, this one. .127 picofarads, and it is a 158 picofarads. So on the low end, it's not measuring well, but that's to be given. What does it say? How far down does the machine say it can measure in capacitance? Let's get the book out of here. Oh, sorry about the 10 nanofarads. So it only goes to 10 nanofarads. So this is way below. All right, I think we'll do one more test here. I don't know if you've noticed, but there's this funny number here. That's the room temperature in centigrade. It's just always there. Don't know why, but it is. And we're in auto mode, so it's saying, hey, there's nothing on. So let's plug in the temperature probe, and it is defaulting to continuity. So that's what it's autoing. It autos between these three things: voltage, ohms, and continuity. Those are the three things it chooses. Otherwise, you have to choose manually. So one of the nice things about clicking the button instead of turning those big rotary dials is those big rotary dials are actually a failure point in multimeters. So I don't know if this one will last longer, but it is something to think about. And so it's now displaying Fahrenheit here and centigrade here. And if I grab the probe, the temperature is going up, and there you go. So it does measure. And if you want to go back to auto, you just hold down and it goes to auto. So there you go. I would say, you know, if you like the big numbers, that's a nice thing. Maybe you like clicky buttons, that's a nice thing. It seems well built. So I'll put a link down below if you want to pick one of these up, and there you go.